Alright guys, welcome to this page of the notes. What we're going to do is we're going to continue with sort of this idea of solving a system of inequalities, and we do that by finding the solution region, which is the area that is shaded, and because it's a system, we're looking for where that shading overlaps. So let's go ahead and take a look at another one. I've given you a system of inequalities here. Let me go ahead and run through all 4 steps and then I'll graph it for you, but I'm going to step over here so I get out of the way so you can see my work. Here we go. Step 1, I graph the equation instead. So y equals negative 2x plus 5. Well, that's going to be easy to do. It's in slope-intercept form. Y equals mx plus b. That's my y-intercept, and that is my slope. Easy peasy. Step 2, do I need a solid or dotted line? Well, since it's less than or equal to, that's going to be a solid line. Because this goes through y equals 5 and my slope is negative 2, it is not going to go through the point 0, 0, so I can use 0, 0 as my test point. And that means in step number 4, we plug that in. So y is less than or equal to a negative 2x plus 5. Plug in your zeros. 0 less than or equal to negative 2 times 0 plus 5, which means 0 is less than or equal to 5. True statement? Yes, it is. Yeah, that's true. Yeah, 0 is less than or equal to 5. Let's go ahead and throw all that stuff on my graph. See if I can figure out where that shaded region is at. So here we go. I have a coordinate plane for you. Graph it in red. 1, 2, 3, 4, 5. There's my y-intercept right there. My slope is negative 2. That's down 2 and over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. 1, 2, 1. Down 2, 1. Down to 1, or I could go up 2 and back 1, same thing. Alright, let's draw a solid line that connects all those points. Let's see how this goes. This one's awkward, it's really steep. Let's see how this, yikes. Okay, we can do this. We can. Uh-oh. Oh, sorry. Hang on. For a second there while I was drawing my line, my app glitched and it stopped, and then when I picked it up and started again, we can fix this. I want it to be a nice line. I like my graphs looking neat. I'm sure you're the same way. Like, drives me crazy when the line's not right. Oh, I missed it. Alright, well, we're going to give it one more shot. 3 strikes and I'm out. Let's see how this goes. Alright, it's not great, but it'll work. Okay, so I've got my line. It's a solid line because it's less than or equal to, I chose a test point of 0, 0. That's that guy right there. And the test point gave me a true statement, which means I need to shade the test point side. So let's go ahead and grab our highlighter and we will shade the test point side. So that's going to be everybody over here. Awesome. Fill all that in. Shade, shade. Color, color. There is my solution region. A quick note to those of you that are taking this class with me, if you'd like to bring a highlighter to the test with you, I would highly recommend it. In fact, I would bring highlighters with 3 different colors. That way, when you're shading your graph, in case I give you a system of 3 equations, hint, hint, you have 3 colors to go ahead and find your region of overlap. So please feel free to use highlighters on the test. In fact, it'll make your graphs look gorgeous, absolutely beautiful. I love the way the highlighters work. Okay, that's that equation. Let's go ahead, that's the first inequality. Let's go ahead and get the other one. Here we go. You know what? Let's do this one in green. We'll do this one in green. Christmas colors. I know it's weird, but that way you can tell them apart. y equals negative 1/4 x minus 6. Step 2, solid or dotted? Definitely going to be dotted. Step 3, what's my test point going to be? Well, that is not going to go through 0, 0, so I'll choose 0, 0. Again, I apologize. So I know it's not going to go through 0, 0 because my y-intercept is negative 6. My slope is a negative 1/4. There's no way this goes through 0, 0. But if you don't know that, right, if you can't look at your equation and know that it's not going to go through 0, 0, please, once you've got your equation, just graph it. Just go ahead and graph it. I would do this one and this one. Once you know the equation and you know if it's solid or dotted, go ahead and graph it. That way then visually you can check to see that 0, 0 is okay. Again, I've been doing this long enough. 0, 0 is going to work. And it's awesome. If you can see that too without having to graph it, you can see that this doesn't go through 0, 0. Fantastic. Well done. If not, don't worry about it. Just graph it. You'll be fine. Don't mean to make you feel bad. If you don't see that, you shouldn't feel bad. You just need a little more practice, that's all. A little more practice. Okay. I plug that into my original equation, and I wind up with 0 is greater than a negative 6. Yes. Yeah, 0 is greater than negative 6. That is a true statement. And so here's what I've got. Negative 6. 1, 2, 3, 4, 5, 6. Right there. My slope is a negative 1/4. That means down 1 and over 4. Down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. I could go up 1 and back 4. Up 1, 1, 2, 3, and back 4. Now I need a dotted line, which means it's going to run through here something like this. Hopefully you can see that dotted line through there. Extend your line all the way through the graph. Put arrows on either end so that I know you know that graph just keeps going. My test point, which is right here, there, 0, 0, gave me a true statement. Since my test point is above the green dotted line and it gave me a true statement, that means everybody above the line would be true. So we shade that entire region. Oops, I need my highlighter. Sorry. There we go. Alright, got a lot of coloring to do on this one. Take your time. Get all that filled in. Alright, the highlighter turned my line green. Let me just go over that again real quick so that that is not confusing. I don't want that to be confusing in any way. Right, that's that red line through there. So where's the region of overlap? Well, the red was everybody down here. The green is everybody up here in the region of overlap. Yeah, you guessed it. That's everybody right in here. Everybody right in there. Awesome. So there we go, doing a graphing a system of inequalities, finding the solution region by finding the region of overlap. Let's try another one. Alright, just because I think we're probably getting the hang of these, I probably won't waste quite so much time with the shading with the highlighters. I'll just graph it. We'll figure out where our solution regions are, and we may even be able to visualize what's going on here. So let's go ahead and run through these real quick then. Alright, step 1. Oh, hold up. No, wait. Before I can even do step 1, I actually need to solve these equations. These have not been solved for y yet. So we're going to need to do that first. We're going to wind up with a negative y is equal to minus 2x plus 4, which means y would be equal to a positive 2x minus 4 because I have to multiply everybody by the negative. This one over here is going to be 2y is equal to negative 4x minus 2. Divide everybody by 2, and y is equal to a negative 2x minus 1. Okay, fantastic. Now that I've solved those guys for y, now we're all set to run through our 4 steps. So let's go ahead and do that. We will graph y equals 2x minus 4. It's going to be a dotted line because I'm strictly greater than. Step 3, that is not going to go through 0, 0, so I will use 0, 0. And step 4, sorry if I'm standing in the way, let me move over here. I'm going to have y, nope, sorry. I actually have 2 times 0 minus 0 is greater than 4. Remember, you got to use the original equation. Use the original equation, and this all comes out to be 0 is greater than 4, which is false. Awesome. This one, we're going to graph y equals negative 2x minus 1. Am I standing in the way? I'm not standing in the way of that one. Fantastic. I'm just going to stay put. I'm going to stay right here. 2, solid or dotted? It's solid. 3, that is not going to go through the point 0, 0, so I will use 0, 0. Make sure you use the original equation in step 4, so I'm going to have 4 times 0 plus 2 times 0 is greater than or equal to a negative 2. I wind up with 0 is greater than or equal to a negative 2. Hey! That one's true. So here's what I wind up with. I wind up with one that gives me a false statement. I wind up with one that gives me a true statement. Well, let's graph both of these lines and see how this comes out. I will graph this one in red. I'll graph this one in green, and here we go. Negative 4, 1, 2, 3, 4, right there. I have a slope of 2. That's up 2 over 1, up 2 over 1, up 2 over 1. Or I could go down 2 and back 1, down 2 and back 1, down 2, back 1, down 2 and back 1. All right. That is a dotted line. And then my other one, my green line, I'm going to go through the point negative 1. So there's negative 1 right there. I have a slope of negative 2. That's down 2 and over 1. So down 2 and over 1, down 2 over 1. I could also go up 2 and back 1. So up 2, back 1. And that's going to be a solid line. Make sure you extend your line all the way through the graph, put arrows on either end so I know you know that you just keep going. Okay. Oh, and I'm sorry. I know. I apologize. Please notice I kind of missed my point right there. In fact, let me fix that because that might throw some of you off, and I don't want it to. I'm very sorry about that. Let me see if I can fix that line real quick. Because the way I had drawn it, just because my line got a little squiggly, it looked like it went through the point 0, 0. But it does not. It's close, but it does not go through the point 0, 0 in the way I had originally drawn it. It almost kind of looked like it did, and I don't want to throw any of you off. So 0, 0 is a perfectly good test point for both of these. It will work. Okay, we need to do our shading. My test point is right here. Test point is at 0, 0. Now, for my red dotted line, my test point gave me a false statement, which means I need to shade everybody to the right-hand side of that graph. That's everybody over here and over here, right? That whole side. The green line, my test point gave me a true statement, which means that I need to shade everybody on the, let's see, my test point is to the right-hand side, so I need to shade everybody on the right-hand side. That's going to be everybody over here and over here. So it looks like what's going to happen is this is going to be my solution region. Let me make sure I did that. Oh, wait a second. I think I've got this little note here and forgot to read my note. Don't forget to flip the inequality when dividing by a negative number. So here's what happened to me. I forgot to flip my inequality when I divided by a negative number, and let's see what happened to me. Let me redo this right here. I'm going to wind up with a negative y is greater than or equal to a negative 2x plus 4. I divide everybody by the negative to get the y by itself, which means I have to flip the inequality, and I wind up then with a positive 2x minus 4. Okay, this one over here, I don't think I have to worry about a negative, right? I don't think that happened to me. I would have a 2y greater than or equal to a negative 4x minus 2. I divide by 2. I don't have to flip the inequality, so we're fine there. That'd be a minus 2x minus 1, which is perfectly okay. That all works out. Now what happens if I plug a 0 and a 0? I get 0 is greater than or equal to a negative 1, which is true. If I plug in a 0 and a 0, I get 0 is less than a minus 4, which is false. No, that's okay. Hang on, I was okay. So then what? This should be all right. I'm not sure what is freaking me out about it, but it looks good. We did our dotted line, 0, 0. False statement, so I shade the other side. 0, 0. True statement, so I shade that side. And yeah, I apologize. We're good. It is important to note that you got to remember to flip that inequality when you multiply or divide by a negative, but I took care of it. We were fine, and so we do wind up with that as being our solution region. Sorry about that. I don't know what I didn't like about the answer. For some reason, something seemed wrong to me, but we definitely did it right, and it goes to show you why double checking your work is always a good idea. I got a few more of these on the next page of the notes, so head on over there and I will meet you there. We'll see.